The two major breaks in the way programming languages are constructed these days is procedural programming languages, things like COBOL or Pascal or original version of C, versus object-oriented languages, which is Java and C++ and C# and Python and a bunch of other languages like that. It's important to understand the differences to some degree because procedural programming languages don't have the features of object-oriented languages, but object-oriented languages still do a lot of procedural type stuff. So fundamentally, building software starts with the notion of procedures and the approach towards procedural programming. So in general, what is programming? Some notions is like, hey, you're good at math, you should be a programmer. Or you're a programmer, you must be good at math. Well, being good at math doesn't necessarily mean you're going to be a great coder. Math helps, but it's not the essence of what can be called computational thinking. A little bit more accurate, maybe logic. There's certain elements of math, which is logic, combinatorial algebra, and things like that. Because a lot of coding skills are based around this idea of managing logic, managing the flow of operations. There's a bunch of, if you look at the world of computational thinking, it's a phrase to talk about what it takes to program. Don't love the idea of thinking inside of there entirely, but that's the phrase that's used. It's more like a lens or a mindset, I think. But if you put that lens on, it's about being able to create sequences and being able to create decisions and being able to manage data and a bunch of things like that. And so you might find this very natural already. If you don't find it necessarily to be intuitive and obvious, it's very learnable. Part of what it is being able to dive in, understanding what the computer does, and being able to replicate that in your mind, get an understanding for how the computer wants to behave. So on their own, computers don't do anything. Programs really are built to do something for people. Very few programs in the world aren't based on something that originally started in the real world that people came up with. So if you go and apply for a mortgage application, people have been doing that for a really long time. We don't need to create a new process for that. It's something that people have done in the real world. Our job really as a programmer is to take these things that are happening from the real world, such as managing a bank account or managing a fantasy football league or creating a video game that simulates poker. They're all basically human ideas, and we have to understand both how the computer works and the rules of that game. And so you, as a computer programmer, have to be an expert not only in how to program computers, but in what you're trying to build as well. So let's talk about making a program with something maybe you've done before, like scrambling eggs. We start with real-world instructions of how this gets done. We need to understand the tasks you want to put that, and then we have to work into telling the computer how to do that. Right now it's just a metaphor. We don't do real code. We're not making a robotic program to make eggs, but we are going to make an excellent program here. So the steps we'd put into the real world is, hey, go out and get some eggs and some tools, bowls and spatulas and whiskers and things like that. And so the next thing you do with the eggs, you're going to crack them. And then you're going to put them in a bowl and mix them up a little bit. Maybe you add other ingredients if you have a special scrambled eggs approach. And then you're going to fry them up in a pan and serve them. So that's the real world concepts. And when we write code for those real world concepts, we want our code to resemble that. So we get some eggs and tools. We go through over here. We create an egg. We create a bowl. We create a pan. We create a plate. And then we crack the eggs. So we have some abstraction, procedure, function, method. We'll use a lot of words for that. But there's some abstraction which does this task of cracking eggs. Maybe we create that work. Maybe it's given to us by the egg cracker program that we're using already. We're going to mix the contents up. Now notice here, when we crack the eggs, we hand it eggs in a bowl. When we mix the contents, we hand it the bowl. There's different data that's flowing in and out of this program. And then we're going to fry those contents. Again, the data keeps going from one to the next, then we serve them up in a pan. This is the procedural way to create a program, step by step, coming up with a sequence of events that needs to happen here. So at the end, the procedure, that abstraction we talked about, is the part that does the really big logic. So when we say crack an egg, well, what do? We pick up the egg in our hand, we smack it hard against the bowl, we open it up, we drop the contents in the bowl. Right? That's the breakdown of how that happens. Depending on who you're talking to, you may or may not need to give that level of detail. If you're talking to a grown-up who's cooked before, you just say, hey, crack an egg. If you're talking to a kid who's never done it before, then you need to provide instructions at a little bit more detailed level. Well, guess what? Computers are kids who's never done it before. So often, while it's very convenient to be able to talk at the level of crack an egg, we also want to be able to give instructions for that. And that's where these abstractions, these procedurals, thus the name procedural programming, gets its name for grouping together this list of instructions to accomplish a higher level purpose. And the idea is we take some inputs and we return some outputs with those tasks. So you can think of your accountant as being a high-level procedure. You give them the inputs, which is your W-2s, your bank statements, your mortgage statements, whatever tax data comes in. And the output is your completed tax return and hopefully a refund or maybe a little amount that you owe. That process is a procedure. It's sometimes called a black box procedure because you don't know what happens inside of it, and that's okay. For many folks, not knowing how their taxes gets done is perfectly okay. It's not to know that you can't know. Certainly you could go through and look over their shoulder and watch them do their work. Certainly you could do the work yourself. You could implement that task yourself. But the idea is we have this abstraction, which is called doing your taxes, and I can choose to interact more deeply with that or not as a human looking at it. Our program doesn't care. I just say, do the taxes, and you get something back, you continue on. And that's what allows us to make really big, complicated computer programs easily. So coming back to the code of sorts that we wrote before. Our first several steps here, you can see pops up our different objects. We get an egg right here, we get a bowl, we get a pan, we get a plate. And each of these things are created and popped up, and then they're ready to go at that point. It's setting up the data structure for us to do the work. Then we have steps that we talked about in the real world that get realized in the details of this abstraction. Like we were just talking about, crack an egg. Well, we take the contents out of the egg and we put it into the bowl. That's what's happening in the crack the egg procedure. Now, that crack an egg procedure and the mixed content procedure, there could be some logic inside of there. I could say, hey, mix these contents. I throw an egg in there, and if it sees a hard egg, it would automatically crack it. The point I'm trying to make here is the breakdown of the procedures is based off of the breakdown of the abstractions, which is based off the real-world instructions you want to create. There's more than one way to make this happen. For instance, maybe you don't use a bowl at all. Maybe you take the egg and crack it directly into the pan and stir it up in the pan, and that's the way you do scrambled eggs. You don't put a bowl in at all because you don't want to make the extra dishes, or it has some special formula when you have that little crispy white egg around the edge before you scramble up the rest. I don't know. But that's okay. It's okay to break these up different ways. There's no one and for all way to create an abstraction, to create a procedure. So again, following down, we come through, we put the stuff in the bowl, we fry it up, and then we take the stuff from the pan and put it on a plate and we serve it. This is the way we've resembled the real world into our code and broke it down. Again, this is not all the code. This is just a high-level breakdown, but this is what procedural programming is. It's taking what we'll eventually learn is addition and subtractions and assignments and if statements and loops and all this other stuff. They build up to this idea of procedures. And many programs at a lot of high levels deal mostly with calling these level of things. I have all this level of services, and so I can now crack an egg, and when I mix the contents, I'm also taking that bowl and I'm pouring in flour and sugar and making cookies. And instead of frying contents that doesn't have to be an egg, I could be frying a hamburger. Instead of serving, it didn't have to be eggs or hamburger, it could be a casserole. All these things become reusable components which I can build interesting computer programs later on from. And that's another part of a procedure, is that abstraction. So let's break down the rules of what you have recognizing a procedure a little bit here. So the procedure has a name, crack eggs, and then it has these parameters we've been talking about. The parameters are essential. A procedure cannot be reusable if it does the same thing every time. So think of it this way. If you created a TV that only allowed you to watch not only just the newscast, but only the newscast for Tuesday, October 16th, 2014. That's not a very useful TV, right? The whole idea of a TV is I want it to have many channels. I want it to be real time and change what happens based off of what's on the channel and what I'm watching and what the time of the day is and everything else like that. That's the same idea of a procedure. Watch TV, I'm going to hand in a channel, and then it's going to have a signal from time. The same concept is when we create these abstractions. We want them to do an algorithm, some set of instructions, but we want that algorithm to take inputs in based off of what's happening. Maybe I'm cooking an egg, maybe I'm cooking broccoli, because I want to be a little bit more vegan friendly inside of there. Okay, so the procedure is by its default an abstraction of work to be done. It's going to be written something that we are going to write or we're taken from somebody else. And then when we call the procedure, all we have to know is what's the name, but also we need to provide the data it needs to work with. I can't just say to Amazon, order me food. I have to say, okay, order me this specific food item from this specific place and ship it to my address. There's parameters that have to happen. Same thing here within code. So all this becomes a little bit complex when we scale up, because to some degree the question is, where do procedures come from? As we said, there's a series of instructions to make things happen, but who comes up with those instructions? What's the right way for them to do it? And how, I might break it down one way, you might break it down a different way. Who's right? Who's supposed to be drawing the line between what bowl is used where and what pan is used where if we're talking eggs, or in bigger computer programs, there can be many fuzzier lines to draw. And so we need to find ways to break up our code, but find interesting ways to be able to reuse our code. And after many decades of writing procedural programming and procedural programming languages, folks started to get the feel that it wasn't the best way to break things up. It's a bit too arbitrary, just saying, program does this, that, and the other. That's where object orientation comes in, and we'll talk about that in the next lecture. But I want you to really understand this concept of procedural programming, because after we talk about objects, there's a little bit different structure to the way we do this in objects, but the fundamentals of what we talked about, procedures, lists of instructions, abstractions, parameter lists, all that holds true in object orientation as well. Object orientation is not something dramatically, radically, totally different. It's something that took the best of procedural programming and then organized it in a way that's a little bit easier to deal with and work with once you get the concepts down.